Now we're working with fractions and decimal conversions. And one of the key things that we really need to talk about is the different types of numbers. So in your notes, you have a definition for rational numbers. So please make sure in the 5 notes you write down it's a number that can be written as a quotient, A over B, where A and B are integers, and B cannot equal 0. Remember, you can never divide by 0. The key thing is that you can write every rational number as a fraction. So the key thing is anytime you're thinking rational, it's a number that can be written as a fraction. A terminating decimal is a decimal that ends. It has a final digit. So this is one that will end. 0.5, 0.25, 3.75, those are all terminating decimals. A repeating decimal is a decimal that has a digit or a group of digits that repeat without end. And you know what most of these are also. That would be like for 0.3 repeating, 0.6 repeating, 0.1 repeating. And we're going to talk about how we can convert these. So in your notes, you should be writing down to convert a fraction to a decimal. I'm going to have you, I'm going to write these down. I'm going to pause the video and then I will come back to that in just a minute so that you can see these definitions. So when you convert a fraction to a decimal, you're going to divide the numerator by the denominator. So if you're given the fraction 5/11ths, one way of thinking about it is how many times does 11 go into 5? The other thing is you can put in your calculator 5 divided by 11. And when you put that in your calculator, it comes out to be 0.0.4545. And if we are looking at this, what happens, you'll either notice that it repeats or ends. And in this case, we have a repeating decimal with this one is equal to 0.45 repeating. When you convert a terminating decimal to a fraction, so we're going to look at that in just a minute also. The first thing when you convert a terminating decimal to a fraction is you want to look at the place value. So we're always going to be looking at our place value. And when I talk about place value, we are looking behind our decimal. So we're looking at, is it the tenths place? Is it the hundredths? Is it the thousandths? Okay, so we're looking at the last. The key thing is it's the last number behind our decimal. The last one behind the decimal. And then we're going to look at a few examples here and then also in your notes when we do that. So if you're asked to simplify and we have the decimal 0.75. Now some of you might recognize that one, but if not, you would start with 75 over our last place of the 5 is in 100. So we put 75 over 100. 25 goes into both of these. This is 3/4. What about if I have something like 2.364? If I'm looking at 2.364, I'm still going to keep the 2 as my whole number in front of the decimal. I look at the place value of the 4, tenths, hundredths, thousandths, and I have 364 over 1,000. I can't leave my answer in this form. I need to simplify. So now you want to make sure that you simplify that last. So when we look at that last part of simplifying, we notice that we have 364. Both of these are actually divisible by 4. So I'm going to have 2 is still my whole number. 364 gives us 91 over 250. And we really can't simplify that any further. When we convert a repeating decimal to a fraction, this is one that we're going to probably take a little extra day on. So when we are filling in, you should have filled in the definition of rational. If you need to go back in the video to fill that in. But when we do this conversion, there's really 4 steps. So we are really talking about 4 different things that we need to do to convert this. And we will work on this for probably the next day in class, if not a day and a half or so. The first thing we need to do is we need to write x equals to our given repeating decimal. So if in the case you have 0.48 repeating, you're going to put x equals 0.4848, and you'll write it kind of like that. The next thing we notice is that we're going to multiply, And the key thing that we're multiplying is we're going to multiply by 10 to a power. And the power that we multiply by is going to be determined by how many numbers repeat. So this number is, when we look at it, it's the number that repeat. When I talk about the numbers that repeat, in this case, it's 48. So we would want to multiply by 2, 10 to the second. Now remember, 10 to the second isn't 20, but 100. So in this case, since it's 0.48 repeating, we would go with 10 to the second, which actually equals 100. Now what you're going to do is you are going to multiply that out so that you have 100x equals, and you multiply both sides of this equation by that number. You'll see a little later when I do the example exactly how to do that. The third step is that you are now going to subtract x from 100x or 10x, whatever you're working with. And the last step is to solve for x and simplify. And the key thing is that our fractions always have to be simplified. What you're going to notice with the repeating decimals when we convert it, a lot of times you're going to have to do 9 or 99, and then you need to simplify. You should have also had rational written down. And now right below, we're going to do a couple examples. First thing, at the very top of your paper, way up above these notes, way up above this 5-5 part, up here, you need to write this down. That you need to memorize the decimal conversions for the tenths and thirds. So right at the very top of your page, you want to write down 1/10 equals, you should know that, decimal point 1. 2/10. What is 2/10 simplified? It is 1/5. That is 0.2. 3/10 can't be simplified, is already in simplest form, 0.3. 4/10, that's equal to, simplified, 2/5, the decimal 0.4. 5/10, this is one that you should all know and have memorized. That's 1/2, that's 0.5. If we continue with our tenths, we're going to have 6/10. 6/10 simplified is 3/5, and that is always equal to the decimal 0.6 or 0.6. 7/10 equals the decimal 0.7 or just 0.7. 8/10 simplified to be 4/5, which is equal to 0.8. And our last one, 9/10. 9/10 is equal to 0.9. What about our thirds? You should also be able to do the thirds. That means you should know 1/3 equals 0.0, 0.3 repeating. 2/3 is equal to 0.6 repeating. And the other thing you need to memorize that you also want to put on the top of this page is your ninths. So you should have memorized the tenths, the thirds, and the ninths. And someone said, the ninths, I don't know those. 1/9. These are your repeating decimals. 1/9 is 0.1 repeating. 2/9 is 0.2 repeating. 3/9, you already know this one. It's a third, 1/3. That is your 0.3 repeating. Then you have 4/9, and I'm betting you can guess that that's probably 0.4 repeating. You have 5/9, which is 0.5 repeating. 6/9, recognize it, it is 2/3 in simplest form, 0.6 repeating. So you should be able to finish off 7/9 and 8/9. And if you want, plug it in your calculator and check 7 divided by 9 and see if it gives you that decimal. What about writing a fraction? So right below this rational number, you want to put example 1. And the key thing we want to do is we want to write a fraction as a decimal. So this is what you want to put in your notes. Write a fraction as a decimal. We're going to put 2 examples. So you're going to have below your notes, when you look at these notes, when you look at these notes below this rational number, you're going to have example 1 over here. You're going to have example 3. And then the one with the repeating decimals, we're going to put example 4 over on on this side. So as you're organizing to the below your notes. The first one, 8/11. Now, you could do long division, or you can simply put it in your calculator, 8 divided by 11. If we are looking at long division, 11 goes into 8, can't go into 8 evenly, so it goes into 80 77 times. We now subtract. When we do our subtraction, we get 30. 11 goes into 30 2 times. We subtract and we get another 8, and we notice that this repeats. So our quotient answer to division is a repeating decimal. And how do we write that repeating decimal? At this point, you could put your answer is 0.72 and putting the bar over the 7 and 2 to show it repeats. What about 9/25? There's a couple of ways. One way is doing the division like we do here. 25 can't go into 9, so it goes into 90 3 times, and we do our subtraction. The other thing I've had students do is tell me, oh, if I want to get to 100, I'm going to multiply by 4. So I get 36 hundredths, or 36 over 100, which is still going to be equal to 0.36, and it terminates. So either way is going to work as you are looking at those. The first one is a repeating decimal, the second one is a terminating decimal. If you look at example 3 now, what I want you to write in your notes is write the decimal as a fraction or a mixed number, and we always want to put it in simplest form. So with example 3, we have 2 problems that we're going to do. 0.8. The first thing we want to think is what's the place value of the 8? The 8 is in the tenths place, so we start with 8 over 10. But what is 8 over 10? It simplifies to 4/5, and this might have been the one you memorized, which that'd be awesome. If you didn't recognize that, you want to make sure you write it this way and simplify. What about negative 3.225? If I'm looking at this one, what I want to do first is this negative 3 is going to be my whole number. I'm looking at the place value of the 5, and the place value of the 5, as I look at that, is going to actually be in the tenths, hundredths, thousandths place. So I'm going to put 225 over 1,000. I now want to simplify. That means I want to divide and get a number that goes into both 225 and 1,000. And I notice that I can divide those both, and 9 over 40. So my final answer is going to be negative 3 and 9/40. It cannot be simplified further. I think what we're going to do is for this last example, the repeating decimals, we're going to save this, and I'm going to do a couple of these on the next video that you will watch, and then we'll do those in class. Hopefully this is making sense, and we will work with this first part in class tomorrow. Thanks. See you then.